to Casella.
So we stand between you and lunch, not enviable, but we'll do our best. I think maybe another round of applause for those presentations. Those were incredible. Are we going to have feedback if I sit next to you? I think we're okay. All right. So thank you guys for having us. My name is Abbie Webb. I work in sustainability for Casella. For those who don't know us, we are a Vermont-based company. We were founded in 1975 in Rutland by brothers John and Doug Casella. They started the business with one truck, servicing one customer, the local ski hill, and grew it from there. Today, we have over 1,000 trucks on the road. We employ 3,200 people and growing, and we serve hundreds of thousands of customers across the country. And cool milestone, last year we passed $1 billion a year in revenue. So pretty exciting trajectory for that Vermont-grown business. We're in the business of protecting the environment and public health by managing society's waste. That was dramatic. By managing waste. And really that entails two things. So it's collection. We need to collect material. When folks are done with stuff, they want to get rid of it quick. So we need to collect that material in a way that's safe, efficient, and reliable. And then once we have it, we need to manage it in a way that adds value and that generates a feedstock for the emerging circular economy. So really those two key elements to what we do. Not everything is suited today. We understand this as a journey, so we know that not every single thing in that trash bin over there has a market, has a use today that we can get it to, but we see it as a journey. It's a continuous effort, and I think even with our landfills, we are looking for ways to recover value from the waste wherever we can. I'll step back a little bit. I mentioned the emerging circular economy. So a few stats. 45% of global greenhouse gas emissions come from the way that we as a society make and use our stuff. So we all know about renewable energy and the importance of renewable energy to achieving our climate goals, but I think it's not as well understood that we also need to really fundamentally rethink the way we make and use stuff if we're going to meet our climate goals. Another stat, thank you, another stat, 90% of biodiversity loss stems from the extraction and processing of natural resources. So again, this is not viable. We need to do better. We need to find ways to make things without going back to the source, without going back to nature for everything we need to make new products. And so, that's really the space that we are a part of. We are not the entire system. We are not the entire circular economy, but we understand ourselves as a piece of it. Last year, we recovered over 1.4 million tons of traditional recyclables, organics, and industrial recyclables from the waste stream together with our customers. And we're looking to grow that number to 2 million tons by the year 2030. So really looking to collaborate with all of our customers, including UVM, to achieve that goal. I think I should introduce these gentlemen to my left. So I'm joined here today by Michael Casella, who runs our Northern Vermont facilities, and then Jeremy Labbe, who runs Vermont's only remaining solid waste landfill. And as we look at the acronym for this event, RISE, and for this organization, I think it really resonates with us. I think it's safe to say that all of our favorite projects are those that kind of sit at the intersection of research, innovation, sustainability, and entrepreneurship. Did I get that right? I think I got that right. This is really where we thrive and where we like to play. So we're going to talk a little bit about some projects that we've been working on. Mike's going to talk about some stuff he's been doing down the road in Williston. And then Jeremy will chime in with some very different but equally important work that he's been doing a little further down the road in Coventry. And then time dependent, I can close this out with a few sort of rapid fire examples of other innovation we're working on. So with that, Mike.
Yeah, I want to thank you guys for having me here. I really appreciate the opportunity. We've done a lot of great work with UVM, and some of the professors and actually grad students have been on site helping us with some of projects that we have going on down the road. And it's really a great partnership between UVM and ourselves to help build an understanding of the ecosystem, right? For me, I look at any problem, and I think anyone in this room, like, I would challenge you, right? When you're designing your products and you're building all these things, don't leave out the waste side. Do not, because we're the ones that end up having to handle it. And so I want to talk about our DPAC facility, and that kind of is what brought me here to the table today. We basically built a new organics recovery facility, right? We had a lot of customers that were reaching out that had food that was trapped in packaging and other products that had organic material that could be harvested. You just had to figure out how to get it out of the packaging so that you could get it to an anaerobic digester. Instead of sending that material to a waste-to-energy plant or a landfill, we worked with them and we decided that we had enough material, right? In our business, if you don't have enough material, you really can't make the economics to invest the $2.2 million that we did to build the facility. And then you also need other partners, anaerobic digesters and other end site processors that can actually handle that material. In our business, one of the things that always keeps me up at night, you know, and Abbie always brings projects to me, right? Hey, Mike, do you want to try this? And I'm usually the guy that's like, yeah, I'll try anything, you know. But at the end of the day, I'm also the guy that every day the material does not stop coming, right? So every day at my facility, we have trucks rolling in, dumping 500 tons of material, and it needs a home. So every day that you don't process material or move that material in our industry, it's just piling up. So we built the DPAC facility, have some really great partners, built a lot of redundant systems to handle that material. And we partnered with UVM because some of our concerns back in 2012 when we were at the legislature was, hey, what about contamination in organics? Whether it's depackaging or other organic streams, we really had concerns. And, you know, what are those cost components? So we partnered with UVM and their staff, and they actually built the first protocol for actually testing organics, microplastics in organics, which was a real success, and they've been featured in Biocycle magazine. So through that partnership, we've learned a lot and how we need to move forward. The other piece for me is the process, right? If you think about it, it's a big machine. We bring the material in, whatever packaging is, we actually profile it at the front end. We have a mechanical process that separates it out. So we separate cans from the soda. It's a perfect stream, right? You have liquid soda, and then you have aluminum cans. We recycle the cans. All that material, that liquid material, then ends up at an anaerobic digester, which is producing renewable natural gas. So those are some of the things that we're working on. We're constantly trying to evolve that system. And then I'm going to pass it on to Jeremy to talk about some other emerging contaminants and things that he's dealing with up at the landfill.
So sometimes we talk about innovation, and it has to do with creating new ways to create value out of our resources. Other things, it's a matter of managing consequences to historical activity. And one of the things I would encourage you guys, before I get into my spiel with innovation, is think of the potential long-term consequences of your innovation. So I remember, 25 plus years ago now, when the first Gore-Tex boots came out, and I was so excited about getting my Gore-Tex hiking boots because I can hike Mount Katahdin, and I'm from Maine, and not need to worry about getting wet feet, right? And I was so excited about it. Now today, 25 years later, our task is dealing with those contaminants called PFAs, right? And PFAs are something you may have heard of now because they're becoming more mainstream, especially in Vermont. And they're, for all practical purposes, they work very well. The problem is they create health issues, and they are a forever chemical, meaning they don't break down the environment. And so because we are a waste industry, we get what every single one of you guys in this room no longer want. And a lot of those compounds, the PFA compounds, are very prevalent and ubiquitous in everything we do. In fact, when we first did a study about 3 years ago, actually almost 4 years ago now, on the wastes that were coming into our facility in Coventry, we tested 100 different samples of material. 95 of them came back, so 95% came back with PFAS in it. And you think, well, this is coming from industrial processes. In fact, the reality is the highest hits of PFAS we got was from consumer goods. And a lot of it was bulky waste, things like carpets and rugs and fabrics and couches, like the couch I'm sitting on right now, that actually had high levels of PFAS in it. And so the question is now, well, what is it doing and where is it going? Because we want to know that information. And everybody wants to know that information because we're hearing this word being thrown all over the place. And we see it in different studies. They're seeing, like, again, I'm going back to my roots, back in the St. John Valley in Aroostook County, Maine, which is, if you've ever been there, it's up by the Allagash. It's as far north as you can go and be in the continental United States. And they studied fish up there, and they were finding high levels of PFAS in the fish up there where there is no industry and there was nothing, meaning atmospheric deposition has brought it all over the place. And so anyway, in the waste studies that we found, we said, well, where's it going? So we actually tested the water that comes out of our secure landfills, which we call leachate, wastewater, to see if it's actually just going right down through the bottom into the bottom of the landfills, and we're collecting it and sending it back to the environment. We found, for the most part, that is not the case. Greater than 90%. In fact, our estimations, it's hard to tell because MSW, household trash, right, is so different. One house produces something that's completely different than another house produces. So getting a sample that actually is representative is difficult. But anywhere between 90 and 99% of the material that comes in, the PFAS material, does not go back out. It stays sequestered in the landfill, which is a good story, something good. But that remaining percentage that is coming out, what do we do next? And that has actually been a place of a lot of innovation, a lot of research across the country. And if you're in my industry, you're hearing it thrown around every day. I've learned more in the last 2 years about PFAS than I'll ever want to know. And I'll probably going to learn more over the next 2 years about PFAS. So we were investigating and piloting different ways to treat what is coming out of the bottom of our facilities for PFAS so that we can render that out of the product, and then even our wastewater will be clean of these forever chemicals. And so we're excited about going through this pilot study and actually working with the University of Vermont to actually analyze the data as we go through this. We've chosen a technology which is not new, but it's new to our industry and new to PFAS, called foam fractionation. You're basically bubbling your wastewater, which actually creates air bubbles, and the PFAS likes that interface between air and water, and actually we can kind of skim it off the top, and we can solidify it or eventually destroy it. And there's a lot of research into destruction of PFAS. Because it is a forever chemical, it's very hard to destroy. And so things like, I'm going to throw big words at you, supercritical water oxidation are on the horizon, but they're still in development. And so as we continue this innovation, we're excited about where we're going with this, and we're talking about very low levels we're trying to get it to. In fact, on a daily total, the wastewater we produce, we're talking about less than half a gram of PFAS in there we're trying to get out. In 40 to 50,000 gallons, we're trying to get less than half a gram out. But we've been able to show through bench scale testing that we can get that down to 0.017 grams, which is 17 milligrams, right, in 40, 50,000 gallons of water of the Vermont 5 drinking water standard PFAs. The really cool thing about that is if you eat Lay's potato chips, there's 170 milligrams of salt in one serving of Lay's potato chips. So we're trying to get it down to 17 milligrams, so that's 10% of what a single serving of Lay's potato chips. It's salt, and that's PFAS. I'm just kind of trying to make a comparison and make you guys understand the amount of it. But anyway, we're really excited about innovation. So it's not necessarily just in our world innovation about reducing what we actually produce for waste or reducing what we throw in landfills. It's also about, okay, now we're handling all your material. There's some potential side effects to some of that material that we've been using for the last 40 or 50 years. How do we innovate and handle that so the environment is clean and we're actually cleaning up what we produced potentially even 30 or 40 years ago?
Fantastic. So I think we do have a little time. I'll give a few other examples of just sort of this intersection of sustainability and innovation at Casella, with some problems that we're looking to tackle through our innovation pipeline. One example, and I'm going to go through these quick just to give you a flavor. One example is we have a lot of customers with sort of tricky locations like stadiums, resorts, even some college campuses where the standard cart-based food waste collection service that we offer doesn't fit, it doesn't work. There are variety of barriers. We've been able to work with a company called Incinerator, you've probably maybe heard of them, and their grind-to-energy technology to deploy a couple dozen of their units at customer locations. And what they do is basically just picture stainless steel table in the kitchen. It's got a built-in garbage disposal, for lack of a better word. Commercial scale, the employees push the food waste down the drain, grinds it up, and instead of going to the sewer, though, or into a septic system, it goes to a tank. And then we have sensors on that tank. When the tank is full or close to full, we send out a truck, pick that material up, and take it to a digester. Another example that we're looking at is in the residential space. So we've had food waste service offered in a number of markets for a while now. Adoption is not 100%. It's not even close. So what we're trying to do is understand what some of the barriers are and to help, I guess, whittle away at that, get more folks signed up. And so we are looking at, and you've probably seen these, there exist sort of countertop appliances for the in-home processing of food waste. It's something we've been monitoring for a while, but we think we've seen a couple breakthroughs lately that are making this accessible to customers, and something that perhaps through a business model, in conjunction with what we're offering today, we'd be able to provide that convenience and better experience for the customer, while also having much improved collection logistics in terms of the product at the end. I would love to keep going. I'm going to do the really rapid fire. The other areas of innovation, we've been doing stuff with mattress recycling, textile recycling, reusable food serviceware, really cool circularity pilot with a key partner around single-use medical devices. I could have talked for a long time. I think I'll cut myself off there. The last one, it's not all flashy things. We have sort of an interesting pilot underway with TerraCycle, New Jersey-based company, to basically provide a way to start recycling some of those hard to recycle materials that are not suitable for processing in a MRF. That's our industry word for a recycling facility. And so what we're offering there, if you know of them, you may know of the box program that they offer, where you can put all your chip bags or your wine corks or your flexible plastic packaging or styrofoam, put those things in a box and mail it to their facilities. We think we can do better than that in terms of efficiencies, and in fact, we've been able to prove that. So what we're offering now is a pouch-based service where folks can purchase these pouches, fill them up with the item that they're looking to recycle, and then scan a QR code. We'll come by, pick it up, and get it down to New Jersey for you. And that's actually, so far, early results are good, and hoping to scale that up. You can learn more at TerraCyclePouch.com. I think with that, I don't know, have you guys been doing like question and answer to wrap these up, or does that work? Okay, fantastic.
So maybe 15 or 20 years ago, I was at a renewable energy conference at Penn State, and they did something called Plastifuel, which was UL listed and worked primarily at that point with dirty agricultural plastic that then got turned into a fuel. It cost $20,000. It rode on the back of a trailer. I went to the Vermont Department of Ag and said, hey, let's buy one because we've got tons of dirty plastic in the state. And it's only 20 grand. We'll go farm to farm. We'll pick up all this dirty plastic. They didn't do it. They went to Cornell, where every farmer had to wash and fold their plastic into a 3-foot by 3-foot diameter. Failure, obviously. So we create tons of dirty plastic, not only agricultural. And there are companies that are out there that turn plastic into fuel affordably. Like there's one company in South Africa I've worked with a little bit called Recor. And for under 20 grand, they make a kind of a batch or a continuous reactor that turns dirty plastic into kerosene, gasoline, or diesel. So my kind of idea was, right now we have Coventry. We have one, I think maybe only active landfill in the state. So what if we decentralize dirty plastic to turn it into diesel to run town trucks, and people can bring their dirty plastic to get their roads plowed? And is Casella doing anything with more decentralized use of dirty plastic to turn it into fuel? Because they're so, like Recor is a great example. Yeah.
Fantastic question, and I think Mike might have something to say, but agricultural plastics are absolutely on our radar. I have spent a little time with the Cornell RAP program, as it was called. I think their funding ran out, and I'm not sure they're doing it anymore, but don't quote me on that. We should circle back. This is adding a little an item to my to-do list. It's high volume material. It's generated across the countryside, and we don't have a great solution for it today. I don't think we particularly like receiving it in our facilities. I think it's kind of a pain to manage in our trucks as well as at the disposal end of things. So we would love to find a solution. I think where we've landed in the past as we've looked at this is, we can logistically do it. but we end up pretty reliant on a single or maybe one or two outlets. And if those go under, we're in trouble. We usually try to have 2, 3, 4 outlets before we would move forward with a project. And it's also consistently been a cost for the farmer. We haven't been able to come up with a business model that would save them money, which is what they were really looking to do. So that's a little bit dated. That's probably dating back 3 or 4 years for my last look at it. But Mike, do you have more to add?
No, we did a farm ag plastic pilot, probably, I think you were somewhat involved in that one. That might have been my own harebrained idea. And we started collecting farm ag plastic, and we were trying to send it to a recycling market, and we had to keep it extremely, extremely clean. And we just couldn't get it to that folded and neat. And then when we'd send it to the end market, to the mill, they would not actually process it. I have not looked into too much technology. I know there was a company over in Groveton, New Hampshire, that was going to try to turn it into a biodiesel at one point. And I had a lot of customers that were looking at the same thing because we're trying to help them with those type of opportunities. But I'm the guy that says, show me what you're doing and show me how you're processing and handling the material. And when we went to the facility, there was three football fields full of dirty plastic. And for me, I sit there and tell, we're not going to be part of that, right? Because we don't want to be the people that are bringing material, dumping it somewhere with the hopes that it's going to be processed and turned into a beneficial reuse, right? We really need to own that process from the start to the finish to really know what happens and what are all the environmental impacts of that whole process, right? So I think the technology is there and it will come at some point. I just don't know how involved we are right now with it. No, we looked at one probably about 5 years ago. Again, it was a gen set that they used on military bases. It was basically a gasification system. Another customer of ours that they actually would plant them in a military base in Iraq and other things like that. They'd make a gas to power the actual base. And most of your attacks, I guess, come when you are either bringing raw product in, or shipping your waste out. So they were trying to say, hey, how do we eliminate one of those points? So they built a small gasification system. But the regulations too, that's another piece for me, is the regulation, air quality, all those other permits that you have to get. That is some of the challenge there. But I'll happy to get your information and see what's out there, because those are all things that we are looking at.
Any other questions?
Hi. So last year, the Davis Center stopped composting bioplastic foodware because CSWD would no longer take it. They couldn't process it at their facility. And so I was wondering, is Casella doing anything to break down and compost bioplastics? Thank you.
Yes, we get this one a lot. So we, in terms of our approach to how we manage food waste, we like to work with the local municipally run, farmer-run facilities. So to the extent possible, we try to support those local businesses by delivering feedstock to them that meets their spec. So when the local facility was able to accept BPI certified plastics, we could bring those to them. But when they changed their process and we're no longer able to do that, we changed our guidance. And so we've tried to be responsive to those customers. And Burlington is not alone in this. I will say we went through the same transition in Boston, in Ithaca, New York. Really, there are still places that accept BPI certified products. They do break down. I've seen it. But every facility is different, and so we really need to sort of be responsive to the local technology and the local systems. Would love to think more about, could we do a separate collection or a reaction, or so somehow make the logistics work to accept that non-acceptable material in a different way. But to date, we don't have that.
Yeah, and we could take that material at the DPAC facility, but at that point, you would still, any of that product would end up in the residual stream, right? Because the DPAC facility is actually built to take packaging from food. So all that packaged product would end up in the residual stream. So for us, it's, it's still going to end up in the residual stream. We might as well move that material out.
And I think it's also, it bears saying that this is a space where we could leapfrog a little bit to reusables. So I think that's where, a lot of our campuses that were disappointed to after they had gotten all the compostable ware in place and now had to pull it back, that's where we've turned our attention is how can we deploy reusables in a more efficient and holistic way.
I have a different flavor of question for you guys. It sounds like you're doing tons of cool projects, and you're probably working with a lot of different companies, entrepreneurs doing that. This conference is about entrepreneurship. So I'm curious, what are the kinds of companies you work with like, and how does that process work? And when you see a problem, how do you identify who you're going to work with, or do they come to you with ideas? I think we'd all love to hear some about that.
Yeah. I'd love to tell you we have like this process and like they go through this gauntlet and then we prove, it's very haphazard.
It is a gauntlet.
Okay, there's a gauntlet that happens, but I think it's just conversations at events like this. It's happenstance. We meet people. We find a problem. We Google it. We have students say, "Hey, did you check this out?" We really, we try not to leave any rock unturned, and yeah, we just try to do our best to find partners who are going to fit well with us. I think we have the best. I like working with the entrepreneurs. They're nimble. They're excited. They ask a lot of big questions. And I think that can help to push us. We're a larger organization now. Working with younger and smaller groups can help push us. And I think we also bring some value. That lens of okay. You have a business model, but you need to zero in on this, and this, because it's a little farther from reality than you might think. So I like to think it's a good balance. But yeah, Mike is part of our gauntlet at some point, and probably Jeremy too. At some point, we do have to think about scale, and we have to be responsible to our customers and make sure that, to Mike's point earlier, if we're going to work with Magic Box X, that it really works, and it does so in a way that's environmentally and socially responsible. Do you have more to say on that, guys?
Yeah, I'll add, we work with entrepreneurs internationally as well, and in the technologies we're looking at, particularly with what I talked about, we're pulling technology in from Australia, because there's other cultures that tend to have a little bit more advanced, infrastructure. Now, when we look with these entrepreneurs, we're also looking for scalability. To Abbie's point, we get calls weekly from people who say they have the the best bread slicer ever since bread slicers, right? And so that process of vetting it out, where we end up is we funnel it to the people who are experts within our company in those different areas, and they have a chance to vet it out against the 6 or 7 others they've gotten from the past 3 weeks or 4 weeks that claim to do this X or Y. And for me personally, someone that I can talk to that actually knows the guts of what they're trying to do gives me a lot more understanding that maybe this is a technology that is worth looking into versus just talking to the sales guy that they've hired to sell the product, who doesn't know a lot about the product. Talking to the guy or the girl or whoever it happens to be, who is actually the one who developed the product, is really important to me.
So I want to be mindful of time. I think that's probably a good place to stop. I just want to reiterate again, this has been a really inspiring event. The pitches were fantastic, and I think we feel really fortunate. We love working with colleges because it's both, there's this raw academic research happening, which helps us answer big questions, but it's also a fantastic testing ground for us to try out new things and prove out, if we can make them work here, maybe we can make them work down the road in the city, and then from there take it throughout the rest of the state and beyond. So just want to thank you all again, and thank you to UVM for hosting this, and enjoy lunch.
Thank you.